Good morning. Good morning, everyone. How are you all? Good morning, guys. How are you all? Let me see who all are present. Let me see, guys. Just let me check in the chat section. Good morning, everyone. Good morning. Please tell me in the chat section, are we live? Are you able to hear me? Is the audio and video clear? Just tell me in the chat section. Good morning, everyone. Good morning. I'm not able to see your chat section. One second, one second, one second. Yes. Now I am able to see. Yes. Good morning, Rahul. Good morning. How are you? Good morning, Rahul. How are you? Yes. All right. Who all are present? Just give me a just just give me a thumbs up in the chat section. Who all are present? I'm also good. I'm also good. Who all are present? Just give me a thumbs up in the chat section, guys. Who all are present? Let me see. All right. I welcome you all to Unacademy, India's largest education platform. This is Let's Crack NEET UG English platform. All right, we are on English platform, and I'm Nitesh Devnani. I have 5 years of teaching experience, and I have taught over 2,000 plus students in your NEET examination. All right. Now see, let me tell you about the subscription plan. What are the benefits you will be getting if you plan to buy the subscription plan? Alright, first of all, you need to download this Unacademy learning app. Just download this Unacademy learning app after this session. Alright, yes. See, there are two types of subscription. Alright, first type of subscription is your plus subscription. Plus subscription, you will have daily live classes, you will have live tests and quizzes, there would be structured courses, as well as you will have unlimited access. Lot of access you will get in your plus a subscription. All right, in your plus subscription you will be getting all these things. Now for the iconic subscription, if you go for iconic subscription, you will have all the benefits of plus. You will have all the benefits of plus, as well as you'll be given a personal coach, expert, a personal guidance you will be given. You'll have your test analysis. All right, after your test you can analyze what are your weak topics, on what topics you need to work on, and you will be given a study planner. You will be given a study planner also, which you can revise on a weekly basis. All right, now see, in the plus subscription you will study from India's best educators, interactive live classes, structured courses and PDF, as well as you'll have live tests and quizzes. In the iconic subscription you will have all these benefits, as well as a personal coach would be given. You'll have a study planner, experts guidelines would be given to you, and you can also analyze your test. All right, yes. Yes, see, there are free classes also. You just need to download this Unacademy learning app. You need to download this Unacademy learning app in order to access these free classes also. All right, so these are some of the educators in our platform. Yes, so see, let me tell you about the pricing, about the iconic subscription plan. Whenever you buy the subscription plan, you need to apply this code Nitesh YT. Nitesh, YT is my code. You will get maximum possible discount. Alright. 6-month course will be getting at 34,200 rupees. 12-month course will be getting at 58,500 rupees, and 24-month course will be getting at 90,000 rupees. But you need to apply this code Nitesh YT. Very, very important, so that you can have a lot of discounts. Alright. Yes. So let me tell you about the pricing of plus subscription. Again, you need to apply this code Nitesh YT. Nitesh YT. All right. You'll get lot of benefits. You'll get extra 10% off also. All right. So I would recommend you to go for, if you are a 11th standard student, you can go for 24-month course, which you will be getting at 50,400 rupees. All right. And if you are a dropper, or if you are in 12th standard and you are planning to buy a subscription, 12-month course would be at 34,650 rupees. All right. But you need to apply this code Nitesh YT in order to get 10% off. All right. Great. Fantastic. So these are the benefits as I have explained you before. So today we are going to start our atomic structure lecture 5. Let me see who all are present. Good morning Rahul, good morning Krishna, Tamil, Ilakya, good morning. Hello Kalai, hello Ritu, hello Richu. How are you all? Hello Rahul. How are you all guys? Are you revising all the things? This is your atomic structure lecture 5. In yesterday's class, we have completed Bohr model. In our previous atomic structure class, we have completed Bohr model, right? So you need to revise and you need to keep on practicing questions. Good morning, Nishtha. Good morning. All right, you need to keep on practicing questions also. We have completed this Bohr model. Alright, this was very important. I have explained you in my previous class only. This was very important. Alright, I hope you guys are practicing questions. Just give me a thumbs up in the chat section if you guys are practicing questions. Just give me a thumbs up in the chat section if you guys are practicing questions. Yes. Able to solve questions? Tell me in the chat section. Are you guys able to solve questions now? Are you guys able to solve question? Yes. Fantastic. Great. Very good. Yes, that's the main motto, right? We are teaching in such a way that you are able to solve your numericals and your questions on yourself. All right. Okay. So if you are able to solve, yes, it will come, na? Keshav and Rahul, it will come with the time. You will be more comfortable as we proceed with our chapters. All right. Okay. So one more question for you all. Let me give you one question and then we will move forward. All right. The question is, in hydrogen atom, energy of electron is minus 3.4 electron volt. Find its kinetic energy. Find its kinetic energy. What should be the answer? Yes, try this question. What should be the answer, guys? What should be the answer? Yes, I've explained you that the ratio which I have explained you, you are given with total energy, you are given with minus 3.4 electron volt. All right, you need to find kinetic energy. Just simply drop the negative sign. All right, you will get 3.4 electron volt. All right, and if you need to find a total potential energy, just simply multiply 2 with your total energy. Simply multiply total energy with 2. So 2 into minus 13.6, which is your minus 27.2 electron volt. So this is your potential energy. This is your sorry, minus 3.4, no? Yeah, minus 3.4. Yeah, minus 6.8 electron volt. This is your potential energy. This is your kinetic energy. All right, clear, guys? I've explained this before. Okay. So shall we move on to our new topic today? Shall we start our new topic, guys? Yes. Great. Great. Yes. Today we are going to study about hydrogen spectrum. Hydrogen spectrum. Today we are going to study about hydrogen spectrum. All right. So first, let me tell you what is the spectrum. First, what the question arises is, what is spectrum? The main question is, what is spectrum? All right. So see, you have your you have your prism. This is your prism. All right. This is your screen. This is your screen. All right, and you are passing light. You are passing light through this prism, and you want to observe the pattern on the screen. So what happens is, light is being passed here, and light is deflected at different angles. Correct? The refraction occurs. Your light is deflected at different angles. All right, you're here on this screen, a pattern is observed. Here on the screen, a pattern is observed. Correct? This pattern is known as your spectrum. This pattern is known as your spectrum. Means, whatever pattern you are observing on a screen, that is basically known as a spectrum. So we are also going to analyze some spectrum. Spectrum of what? Hydrogen spectrum. Spectrum of hydrogen. See, this was spectrum of light. Your light was refracted and a pattern was observed. All right, but in our course we are going to study about hydrogen spectrum. What are the aspects of our hydrogen spectrum we are going to study? All right. Yes. Great, Piyush. Yes. All right. Now see, your spectrum can be of many types. Your spectrum can be of many types. Spectrum can be of many types. See, spectrum can be continuous. Spectrum can be continuous, and spectrum can be discontinuous. See, like your rainbow. Rainbow is your VIBGYOR. Rainbow is your VIBGYOR. Na? Here it is your VIBGYOR. All right. So this is your VIBGYOR. This is your VIBGYOR. You cannot differentiate between this and this. These two colors. You cannot differentiate between this yellow and this orange. Right? All these are what in continuous in nature. All these are what in continuous in nature. So your spectrum can be continuous also, where you cannot differentiate between two things, and it can be discontinuous also, where you can easily differentiate. All right. Similarly, your spectrum can be band spectrum also, and your spectrum can be line spectrum also. Band spectrum means the pattern observed is like this. These are small bands. These are small bands. All right. Or your spectrum can be line also. These separate lines can also be observed. Are you getting my point? All right. Yes. Similarly, your spectrum can be absorption spectrum, as well as your spectrum can be emission spectrum. Now, okay, now tell me, I need to ask you something. Now tell me, if an electron absorbs energy, will it go to higher orbits? Will it jump to higher orbits from lower orbit to higher orbit? Tell me in the chat section. Give me a thumbs up if this is possible. If an electron absorbs energy, will it jump to higher orbits? I've explained you this in our Bohr model. Yes, yes, it will jump. Yes. So absorption spectrum means lower orbit. Electron is jumping from lower orbit to higher orbit. Correct? Alright. Now again I have explained you that electron, when it jumps from higher orbit to lower orbit, it emits radiations. On emitting radiation, on emitting energy, it will jump from higher orbit to lower orbit. So emission means electron is jumping from higher orbit to lower orbit. Correct? Correct? This is correct, right? So these type of broad classification is your about your spectrum. So we are going to study what? We are going to study hydrogen spectrum. So hydrogen spectrum is discontinuous in nature. All right, hydrogen spectrum is line spectrum, and hydrogen spectrum is emission spectrum. So hydrogen spectrum is discontinuous, it is line and emission spectrum. All right, are you getting my point? Is this thing clear, guys? Up to this point, is everything clear? All right, it will be discontinuous, means there you can differentiate between two lines. All right, different lines would be formed. And emission means electron would always go from higher orbit to lower orbit. Electron will always go from higher orbit to lower orbit. All right, yes, great. Now see, we need to study. There were 6 lines observed in hydrogen spectrum. There were 6 lines observed in hydrogen spectrum. There were 6 different lines observed in hydrogen spectrum. All right. Now, Nishta, the pattern which was observed was only for your emission only. All right, was for your emission only. All right, the scientists which observed these patterns were only for your emission spectrum. All right, there were 6 lines which we need to study. All right, now see, lines or series, we can call them as series also, we can call them as series lines, or we can call them as series also. All right, okay, now see, there are different series. All right, transaction is, it is what? Emission, na? It is what? Emission spectrum, means higher orbit to lower orbit. Correct? Higher orbit means N2, lower orbit means N1. For higher orbit, I am just saying shell number as N2. For lower orbit, I am just saying shell number as N1. All right, this thing is clear. Now see, different series were being invented. See, series, I'm making a table. All right, this is N1, this is N2. All right, this is your series which I'm going to make. I'm going to make a table. Now just pay attention here. Now see, you have your first series as your Lyman series. The series are named on the scientist who invented it. All right, Lyman series. Lyman series means the electron, it is an emission spectrum. Correct? Electron is jumping from higher orbit to lower orbit. Correct? So which lower orbit it is coming? In Lyman series it is coming in n1 equals to 1. Now from where it can come? Now from where it can come? It can come only from higher orbit. Higher orbit means it can come either from 2, 3, 4, 5 up to infinity. Correct? Correct. Second is your Barmer. Second is your Balmer series. Balmer series, the lower orbit is fixed for every series. For Balmer series it is what? 2. Now tell me what can n2 be? Now tell me what can n2 be? What all shell numbers n2 can be? Tell me in the chat section. It can only be 3, 4, 5, 6 up to infinity. Why? It cannot be 1. It cannot be 1. Why? Because 1 to 2 means absorption, lower to higher. No, 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 no. We need to only study what emission means. N2 is always more. N2 is always more and N1 is always less. Alright. So we are studying emission. We are studying emission spectrum. Are you getting my point? Third, Lyman-Balmer. Third is your Paschen. Now lower orbit is fixed as your third. Now what n2 can be? Tell me in the chat section what n2 can be. What values n2 can have? N2 can have as 4, 5, 6 up to infinity. Correct. Only higher orbits are possible in your n2. Lyman-Balmer Paschen. Fourth is your bracket. Alright. Lower orbit for bracket is fixed is 4. Your n2 can be higher orbits, your 5, 6, 7 up to infinite. Alright, are you getting my point? Next is your fund. Next is your fund. Alright, fund, the P is silent here, but you pronounce it as fund only. Alright, the landing, the lower orbit is fixed, it is 5, 6, 7, 8 up to infinite. Alright, sixth and last, there was 6 series. Last is your Humphrey. Last is your Humphrey. Alright, Humphrey, the lower orbit is again fixed 6. So what can be the higher orbits? More than 6. 7, 8, 9 up to infinite. Are you getting my point? Are you getting my point? Yes. Okay. Great. Now see. If an electron, now suppose if an electron jumps from 3 to 1. Suppose if an electron jumps from 3 to 1. Would there be any energy difference between third shell and first shell? Would there be any energy difference between third shell and first shell? Great, Somesh, great. Yes. Have you applied the code, Nitesh YT? Just tell me, if an electron jumps from third orbit to first orbit, if an electron jumps from third orbit to first orbit, would there be any energy difference? Would there be any energy difference? Yes. If there would be energy difference, so there would be some wavelength also, na? Energy energy you can calculate as hc by lambda, na? If there is energy difference, you can there would be surely having a wavelength also. Now that wavelength, where that wavelength is being associated, alright, that would depend on your series. Means this Lyman series, all your Lyman series lies in your ultraviolet region, UV region. Do you remember I've made that spectrum? I have made that spectrum. Do you remember it? I have made one spectrum: ultraviolet, visible, infrared. Do you remember it? Yes. So see, your Lyman series is lying in ultraviolet region. All right. Your Balmer series lies in your visible region. Visible region. Visible region means VIBGYOR. Visible region means VIBGYOR. Alright. Your Paschen bracket fund Humphrey. All these lies in your infrared region. All these lies in your infrared region. Are you getting my point? All right, because based on some energy difference, there was some wavelength. Now that wavelength is associated with your region is associated with your each and every series. Is this thing clear? Give me a thumbs up in the chat section if this thing is clear, guys. Give me a thumbs up in the chat section if this thing is clear. Just take a screenshot of this. Just take a screenshot of this. Yes. All right. Great. Great. Rahul, Kalai, Richu, Priyanshi, Supriya. Fantastic. Great. All right. Great, Somesh. Great, Keshav. Great, Nishtha. Yes. Okay. All right. So let me visualize this. Great, Kalai. Yes, great. Let me visualize this. Suppose this is your n equals to 1. This is your first shell. This is your second shell. This is your third shell. This is your fourth shell. This is your fifth shell. This is your sixth shell. This is your seventh shell, and like this you have your infinity shell also. You have infinite number of shell. Great, Tamil. Yes. All right. Now see. If an electron jumps from 2 to 1, it is lying in Lyman series. Always if an electron is coming in first shell, it is electron. If an electron is coming in first shell, it will lie in Lyman series. N3 to N1, N4 to N1, like this. Similarly, infinite to N1. All these are what? Lyman series. All these are Lyman series. Alright. Now suppose if an electron is coming from 3 to 2, or 4 to 2, or 5 to 2, similarly, or infinite to 2, this will lie in Balmer series. Similarly, your Paschen bracket fund Humphrey. Is this thing clear? Now you guys can make it, right? You guys can make this series. Understood? Is this thing clear, guys? Is this thing clear? Now, as I have told you that if there is a jump in electrons, it is jumping electron between different orbits, then there must be what? Some wavelength. The formula for wavelength. Now I am directly writing the formula for your wavelength. How can you calculate wavelength? 1 by lambda equals to RH z square upon 1 by n1 square minus 1 by n2 square. This is your formula to calculate wavelength. Now what is RH? RH is your Rydberg constant. Alright, what is the value of RH? Value is 1.1 into 10 to the power 7 meter inverse. Alright, this is the value of your Rydberg's constant. Directly we will be using this formula in order to calculate wavelength. Alright, I'll give you questions. Don't worry, I will give you questions also. What is Z? Z is your atomic number. Tell me what is N1 and N2? N1 is what? N1 is lower orbit and N2 is higher orbit. N1 is lower orbit, N2 is higher orbit. Is this thing clear? Oh, I think this thing is not visible to you. Alright, we know this, na? Z is your atomic number, N1 is your lower orbit. N1 is your lower orbit and N2 is your higher orbit. This thing clear? Okay, great, fantastic. Now again, let me explain you. I will explain you series. I will explain you different series, and I'll give you then questions. Okay, then I will give you some questions also. All right, great. Let me explain you first a Lyman series. Lyman series. Here n1 is fixed. Yes, its value is 1. n1 is fixed, its value is 1. Great. Yes. All right. Now see, suppose this is your nucleus. This is your first shell. This is your second shell. This is your third shell. This is your fourth shell. Similarly, this is your infinite shell. Okay, just pay attention here. Just pay attention here. Many different things we are going to learn from here. You just understand one series. All other series will be able to do it by yourself only. All right. Okay. Now see. Now see. If an electron comes from 2 to 1, this is Lyman. If it comes from 3 to 1, this is also Lyman. 4 to 1, this is also Lyman. And if it comes from infinite to 1, this is also Lyman. All right. Now see. Now see. Tell me, in all these transactions, all these shifting of orbits, where your energy change in energy is minimum. Which transaction changes in energy is minimum? Tell me. Which transaction change in energy is minimum? Which transaction change in energy is minimum? When orbits are very close to each other, right? Your n1 is fixed 1. When orbit which is very close to each other, an electron will jump from that that orbit, energy difference would be minimum. So therefore your transaction where your delta E, your change in energy is minimum, is 2 to 1. All right. And where your energy difference is maximum is, where your energy difference is maximum. No, Rahul. According to Bohr, every atom has infinite shells. Now tell me where your energy difference would be maximum. Where your energy difference would be maximum when an electron will come from far away. Far away means infinite to 1. Infinite to 1. Are you getting my point? Alright. Yes. Now tell me delta E we can calculate it as, or energy you can calculate it as, hc by lambda, which we have studied. We have studied this, na? E equals to hc by lambda. Now if energy is minimum, your lambda would be maximum, your wavelength would be maximum. That means lambda max is what? 2 to 1, where your energy difference is your minimum. Now where your energy difference is maximum, your lambda would be minimum. Is this thing clear, guys? Other electrons are for just for excitation. If energy is given, you need a certain pattern and everything for this. Yes. Okay, Keshav, is this thing clear? First tell me in the chat section, is this thing clear? Is this thing clear, guys? Great. Now see, if an electron comes from infinite shell to first shell, it is known as last or limiting. It is known as last or limiting line. It is known as last or limiting line if it is coming from infinite to 1. And if it is coming from your first, like this 2 to 1, 2 to 1, this is known as your first line. First line. All right. Now see, questions would be asked to you as first line of Lyman. Tell me the transaction. Transaction means the orbits. Tell me the transaction. Just like this video if you are able to understand everything. Yes. First line of Lyman, the transaction is 2 to 1. Similarly, this is your second line. This is your second line. Transaction is second line of Lyman would be 3 to 1. Correct. Similarly, third line of Lyman would be 4 to 1. Similarly, therefore, nth line of Lyman, nth line of Lyman would be n plus 1 to 1. N plus 1 to 1. Are you getting my point? Are you getting my point? Nth line of Lyman would be n plus 1 to 1. Alright, is this thing clear? Similarly, see, there is a trick. There is a trick to find the nth line. There is a trick to find the nth line. Whenever you need to find nth line, see, I am explaining you here. Whenever you need to find the nth line of any series, alright, suppose you need to find Lyman series, nth line of Lyman series for Lyman. Nth line for Lyman, where do you go? Always where do you go? At 1. At 1 na? Always you land in first shell. Okay, for Lyman, n1 is fixed, which is 1. So just do n plus 1. Don't worry, I'll give you more examples. Alright, let me explain you now Barmer series. Wait. I will give you more example. Let me explain you Barmer series. Barmer series into n1 is fixed. Second, you are coming in your second orbit. You are always coming in second orbit. Okay, let me draw shells for you. This is n1 equals to 1. This is 2. This is 3. This is 4. This is 5. And this is infinite. Correct? All these are what? Emission electrons, emission spectrum. So this is Barmer, 3 to 2, yes. Similarly, 4 to 2, Barmer, 5 to 2, Barmer. Similarly, infinity to 2 also Barmer. Perfect. This infinity line would be what? Last or limiting line. Correct. Now tell me which transaction energy would be minimum? Change in energy would be minimum. Tell me, in Barmer series, we are talking about Barmer series. Tell me energy difference would be minimum where? Where energy difference would be minimum? When it will come to shell from very close, means your 3 to 2, yes, and your delta E would be maximum. Delta E would be maximum when? Delta E would be maximum when? When it will come from far away, means from infinity to 2. Alright. Now where energy is minimum, your lambda is what? Maximum. Where energy is maximum, your lambda is your minimum. Alright, is this thing clear, guys? Is this thing clear? Yes. Now see, this is your first line. This is your first line in Barmer series. So see, first line of Barmer, what is the transaction? 3 to 2. Correct. Second line of Barmer, second line of Barmer is this. Second line of Barmer transaction is what? 4 to 2. Correct. Similarly, therefore, nth line of Barmer would be, see, there is a trick. Alright, for Barmer you are going to, where are you going? We are going to second shell. In Barmer you are always going to second shell, na? Just do like this, second. Now you need to find nth line, na? Simply add n plus 2. For Barmer we are doing plus 2. For Lyman we were doing plus 1. Why? Because you were going to first shell. Is this thing clear? Is this trick clear, guys? Can you find now nth line? Any nth line you can find now. Is this thing clear, guys? Okay, now similarly see. Now see, third is your Paschen series. Now you guys can do it. You guys can do it. Paschen series n1 is fixed as your third. Alright. Now I'm not drawing again diagram, all those diagrams. Alright. Tell me delta E minimum, delta E maximum. Now where delta E would be minimum, your lambda would be maximum. Your delta E would be maximum, your lambda would be minimum. Tell me the transactions. Tell me the transactions. Tell me the transaction for your delta E minimum. First tell me transaction of your delta E minimum. Kalei, you cannot say 3 to 4. 3 to 4 means absorption, lower to higher. No, no, no. Always we need to go higher to lower. Always we need to go higher to lower. Yes. Delta E would be minimum when it will come from closest shell, means 4 to 3. Alright. And delta E would be maximum when it will come from far away, infinity to 3. Alright. Tell me nth line. Nth line of Paschen. Nth line of Paschen. Tell me. What should be the nth line of Paschen? What should be the nth line of Paschen? Yes, Niranjan, you can surely get. You need to attend regular classes. We are having regular classes at your 9:30 a.m. Yes, similarly, the transaction would be for Paschen, you are going where n1 equals to 3. So just do like this 3. Nth line, simply add 3. Now I think you guys can do it. See, in this atomic spectrum, in this hydrogen spectrum thing, these transactions are very important. There is only one formula which I have told you to calculate a wavelength. What was the formula? What was the formula? 1 by lambda equals to RH z square upon 1 by n1 square minus 1 by n2 square. This is the formula. This is the formula. But first of all, you need to know what is this n1 and n2. Alright, for that n1 and n2, you need to know all these transactions. You need to know all these transactions. Alright, shall I give you questions now? Shall I give you questions? RH value is 1.1 into 10 to the power 7 meter inverse. Z is your atomic number. Shall I give you questions now? N1 lower orbit, N2 higher orbit. Alright, let us do some questions now. Let us do some questions now. Great, fantastic. Alright, alright. You guys need to attempt, alright? You guys need to attempt. Question. Find the first emission line in spectrum of hydrogen in Barmer series in terms of R. What is R? R is your Rydberg's constant. R is your Rydberg's constant. You just need to solve this question in terms of a Rydberg constant only. Okay. No need of calculations, doing calculations. Main is your transaction. Main is your transaction. Come on. Tell me. Formula, I am writing it for you. This is your formula. First emission line in spectrum of hydrogen of Barmer series. Yes, yes, wavelength only you need to find. Obviously, yes. Find the wavelength. Alright, find the wavelength of first emission line. Main thing in this question is to find your transaction. Main thing in this question is to find the transaction. Yes. Main thing is to find the transaction. See, have told you you are given you need to find the first emission line, na? First line of Barmer. First line of Barmer. In Barmer, you are going to 2. Always the landing shell is your 2, na? First line, simply add 1 plus 2, which is what? 3 to 2. This is your transaction. Now simply 1 by lambda equals to R. Z for hydrogen is 1. 1 square upon. Now carefully observe, N1 is smaller, N2 is larger. So it is 1 by 2 square minus 1 by 3 square. Alright. So 1 by lambda, you need to solve this, R into 1 by 4 minus 1 by 9. Yes. So if you'll solve this, lambda would definitely come out to be 36 by 5R. Yes, 36 by 5R. Yes. You can easily solve this. You can easily solve this. Fantastic. Is this thing clear, guys? Is this thing clear? Easy? Easy, right? Okay. Now let me give you some practice for your this transactions only. Find transactions. Find transaction, because this is important. All right. In formula you can always put. All right. Always you need to find transactions. All right. Yes, Ilakya, we can surely calculate it, but I needed answer in terms of your R only. All right. Your transactions are what you need to find. Fourth line of Barmer. I'm giving you a lot of transaction. You need to just find. Sixth line of bracket delta E minimum for fund lambda minimum for Humphrey. Okay. All right, try doing this. Doing these questions. Yes, these are your 5 things you need to find transactions. All right. I've explained you in detail each and everything. Like this video, guys, if you are able to understand everything. Yes. Just do all these. I'll wait for you. Alright, see, the main thing is to find the transaction only. Otherwise, the rest thing you can easily do by putting the transaction values in your formula. That is very easy. And calculations you can easily do. The main thing is to find these transactions. Alright. Okay, you do it, you do it. I'll see. Yes. Everyone attempt this question, guys. Yes. Okay, let me explain you this. Fourth line of a Barmer. I have always told you trick. Just to do first this. Barmer, for Barmer you are going to 2. Fourth line. Just simply add this 4 with this 2. So this is coming out to be 6 to 2. This is coming out to be 6 to 2. Fantastic. Fantastic. Great. Give me answer of second. Okay, I'll ask now. Give me answer of second. Lyman Balmer Paschen bracket means for bracket your n1 is fixed, which is 4. Tell me this answer second. Simply just do this. Simply do this 4 and sixth line. You need to find sixth line. So 6 plus 4. So 10 to 4. Yes. Yes. Now see, delta E minimum for fund. Lyman Balmer Paschen bracket fund. Fund means N1 is your 5. Now you need to find a delta E minimum. Delta E minimum means it should come from very close. It should come from very close. Very close means your 6 to 5. Your 6 to 5. Alright. 6 to 5. Okay. Yes. Now fourth one. Give me everyone. Give me answer for your fourth one. Give me answer for your fourth one. Give me answer for fourth one. Give me answer for fourth one. Then I will tell you how I do this. Now then I will tell you how I do this. For wavelength, how I do this. See, you are being asked lambda minimum. Alright, don't go for lambdas. Lambdas are a bit confusing. Don't go for lambda. Always just write here, if lambda is minimum, your energy difference is what? Maximum, na? Your energy difference it was maximum. Yes. Alright, now for Humphrey, Lyman, Balmer, Paschen, bracket, fund, Humphrey. means n1 is what? 6. Now you need to come to 6 such that your energy difference is maximum. You need to come from infinity, far away. Yes. Alright, so see, lambdas are a bit confusing. Always convert those lambdas into energy thing. If lambda is minimum, your energy has to be what? Maximum. Right? Yes, yes, yes. Alright, now fifth line of Pashchin. Fifth line of Pashchin. The Lyman Balmer Pashchin. Pashchin means n1 is what? 3. So fifth line, simply 5 plus 3. 8 to 3. Yes. Is this thing clear? Are you would you be able to write transactions now? Tell me in the chat section. See, the formula is pretty simple. 1 by lambda equals to RH z square upon 1 by n1 square minus 1 by n2 square. Transactions are what you need to learn. Formula you can easily put. Is this thing clear? Give me a thumbs up in the chat section. Give me a thumbs up in the chat section if this thing is clear. All right. Great. Great. Now there is one more concept left in your atomic spectrum only. Let me explain you. This. There is one more concept left. Great. Sorry, 8 to 3. 8 to 3. Yes. 8 to 3. Yes, Keshav. All right. Yes. Okay. There is one more concept left in your atomic spectrum only. Concept is how to calculate spectral lines. Spectral lines means see, all these are spectral lines only, which I have told you here. See, which I've drawn na, these first line, second line, third line, fourth line. We call these as your spectral lines only. Your name is your spectral lines only. So we need to calculate spectral lines. How to calculate spectral lines? All right. See, now see, for the how to calculate how to calculate total number of spectral lines. How to calculate total number of spectral lines? So total number of spectral lines for n2 to n1. Transaction is n2 to n1, right? We know we can calculate transaction now. Total number of spectral line for the transaction n2 to n1. There is a simple formula for this. Formula is n2 minus n1 into n2 minus n1 plus 1 by 2. All right, you can simply calculate with this formula difference n2 minus n1 into difference plus 1 by 2. You can calculate total number of spectral lines using these formula. Are you getting my point? All right, let me give you question. Find total number of spectral lines for first is your 8 to 3. All right, second is your 10 to 2. Total number of spectral lines you need to find. Yes, try this. You can easily do this, right? This is a pretty easy thing. You just need to apply that formula. The formula which I have given is very much correct. That's the main issue when and you guys don't trust your faculties. You guys don't This is the formula. This is the general formula which you need to apply when total number of spectral lines are being asked. That's the issue. You are learning from two sources. Keshav, you are learning from two sources. Alright. So you'll be confused only. Yes. Alright. So this is your N2, this is your N1. So what was the formula? N2 minus N1 into N2 minus N1 plus 1 divided by 2. Alright. Yes. So simply do this minus this, 8 minus 3, 8 minus 3 into 8 minus 3 plus 1 by 2. This is 5 into 6 by 2. This comes out to be 15. Alright. Now similarly here, difference. Just try to learn with this. Difference is 8 into difference plus 1, 9 by 2. This is 36. Keshav, the formula which you are talking about is only a limited case. Just try to put n1 as 1 there. In this formula, many of you must have studied this. If in this formula, if I try to put n1 as 1, try to put it. That's the main issue, right? You you need to trust your faculties. All right. We have been teaching students for so long. We know how to teach and what to teach. All right. And lot of students have got some great marks by studying from me. All right. So you need to trust your faculties. All right. If you are able to understand from what I am teaching, trust me and then follow it. If you are not able to understand this, there are n number of sources. You can surely study from there. That's your point, right? All right. Great. Okay. Now see. Now in this formula, I have told you how to calculate total number of spectral lines. This was for your total number of spectral lines. This, whenever total number of spectral lines is being asked, you need to apply this formula. Now spectral lines for a particular series, series, like your series were your Lyman, Balmer, Paschen, Brackett, Fund, Humphrey, all those were your series. Now if a question is being asked to you to find the total number of spectral lines for a particular series, how do you find it? Or how do you find it? See, for Lyman, the formula becomes n2 minus 1. Why 1? Because in Lyman you are always going in your first shell. Okay. Balmer means n2 minus 2. Why this 2? Because in Balmer you are going at second shell. Lyman, Balmer, Paschen. Tell me what should be the formula for this. Hello Misha, hello Surendra, hello Babita. We have our classes at 9:30 a.m. Why you guys are late today? Why you guys are late? Tell me formula for your Paschen. Tell me formula for your Paschen. What should be the formula? For specifically for your Paschen only. Formula would be n2 minus 3. Bracket. Guys, tell me in the chat section what should be the formula for your bracket now. What should be the formula for your bracket? Please be active on the chat section. Bracket would be n2 minus 4. Simply. Fund. What should be the formula for your fund? Just like this video if you are able to understand everything. n2 minus 5. And Humphrey, also your N2 minus 6. Alright, so this is the formula. This is the formula. Shall I give you some questions? See, if for a particular series is being asked, this is the formula. If total number of spectral lines are being asked, then previous formula which I have explained you. Okay? Great, Kalai, Supriya, Nishtha, Surendra. Great. Just be active in the chat section. Okay. Now I'll give you some questions. Just tell me in the chat section who all are present first. Just give me a thumbs up in the chat section who all are present. Great, Ritu. Great, Surendra. Yes. Just give me a thumbs up in the chat section. Let me see who all are present. Elakya is present. Okay. Yes. Great, Kalai, Nishtha. Fantastic. All right. All right. Who all are present? Any doubt up till now? Great, Rahul. Yes. Who all are? Any doubt up till now? Any doubt? Great, Mohammed, Nishtha, Supriya. Great. Any doubt? No? Shall I give you questions? Shall I give you questions? Shall I give you some questions? All right. First question. First question. Find. Let's see. An electron. An electron jumps from. An electron jumps from 7th orbit to first orbit. All right. Find. You need to find certain things. Find total number of spectral lines. Find total number of spectral lines, and second is your spectral lines in Balmer series. Okay, do this question. Do this question. Do this question. Also like this video, guys, if you are able to understand everything. Both these questions you need to do this. Yes. Give me answer for both. Your transaction is given to you as 721, mean N2 and N1 is given to you. Yes. Come on, guys, these are pretty easy questions. Okay. See, what was the first formula? First formula was a difference. I've told you trick also to learn. Difference 7 minus 1 6 into difference plus 1 6 plus 1 7 by 2. Always remember with this difference. Alright, into difference plus 1 by 2. Alright, so if we solve this, we will coming out to be 21 spectral lines. First total spectral lines is 21. Alright, now for the Balmer series. Now if it is being asked for Balmer series, what was the formula? What was the formula? N2 minus 2. Why 2? Because you are landing in second shell for your Balmer. N2 is what? N2 is what? 7. So 7 minus 2, which is your 5, is your answer. Is this thing clear? Is this thing clear, guys? Give me a thumbs up in the chat section if this thing is clear. Yes, if this thing is clear, give me a thumbs up in the chat section. All right. Okay. Fantastic. Fantastic. Let me give you. Okay. In our Bohr model, I've explained you one thing. I'm again explaining you. What do you mean by ground state? What do you mean by ground state? Ground state means n is what? 1. First shell. Ground state means n is what? 1. Excited state. Excited state means your n can be anything other than 1, means 2, 3, 4, 5 up to infinity. Correct? I've explained you this also. First excited state means n equals to 2, means plus 1. Alright. Similarly, third excited state means n equals to 4. Similarly, nth excited state means n equals to n plus 1. Shell is your n plus 1. Alright. I've explained this, right? I've explained this thing in our Bohr model. So I've again explained this. These are some of your terminologies which you might encounter during your questions. Okay. Okay. One more question. One more question for you all. One more question for you all. Let me see who all can do this. Let me see. All right. Now, find number of spectral lines in visible region for 8 to 1. For 8 to 1, transaction is given to you as 8 to 1. You need to find what is being asked to you. Come on everyone, tell me. Guys, your answer in the chat section. Visible region means which series? Yes, very good, very good. No, no, Keshav. I was just telling you that I am not ignoring anyone. I'm just telling you that study from a single source. Okay? Yes, yes. I know. You are a regular student. I've been regularly seeing you in our classes. I know everyone here is a regular student. Supriya, Richu, Keshav, Nishtha, Kalai, Rahul, Surendra, Tamil, Supriya, all you guys are regular student. Mohammed, fantastic. Alright, you guys all are regular students. Yes. Okay, now tell me what do you mean by this visible region? Which series is this visible region? This is simply your Barmer. Yes, simply this is your Barmer series. Now for your Barmer series, what was the formula? What was the formula? N2 minus 2. N2 is this higher shell. 8 minus 2, which is your 6. Correct. Correct, correct. Got it. Great Kalai, great Keshav, great Nishtha, Rahul. Fantastic, fantastic, fantastic. Great Supriya. Yes. Okay, one more question. Are you guys ready for one more question? One more question, okay? One more question. Lot of practice we are doing, right? Okay. One more question is, find s- find spectral lines in ultraviolet region uh, during the transaction from fifth excited state, ES is excited state, all right, to first excited state. Come on everyone. Yes, come on everyone. Yes, first of all you need to find the transaction. Fifth excited state means n equals to 6. Your first excited state means your n equals to 2. Simply add 1 to it. So what is the transaction? 6 to 2. Yes. Now give me a final answer. You are being asked in your ultraviolet region. Give me a final answer. Give me a final answer. Yes. Now there is a trick in this question. I knew this you would answer this. Some I knew this you would be answering these only. Alright, I knew this, yes. But you are not correct. You guys are not correct. Now let me tell you. A ultraviolet region means we are talking about Lyman series. Perfect. Now tell me your electron is present in your sixth shell. Electron is present in your sixth shell. 6, 5, 4, 3, 2, and it is your 1. But all your transactions are from your 6 to 2, between these two shells, from sixth energy shell to second energy shell. All transactions all transaction between 6 to 2 only. Sixth shell to 2 shell only, there are all the transaction. Now tell me yes, Nishtha, that is the trick. Yes, Rahul. Now tell me whether an electron is coming in your first shell or not. All the transactions are from 6 to 2 only. Electron is never coming in your first shell. It is always jumping in between 6 to 2. It is never coming in your first shell. If it is never coming in your first shell, then answer is your 0. There would be no spectral line in your Lyman series. Are you getting my point? It is never coming in your first shell. If it is never coming, this means your answer is 0. So you always need not to apply just the same formula, n2 minus n1, n2 minus 1 for Lyman. No, first check whether it is coming in your shell or not. First you need to check, na. Is this thing clear? Is this thing clear, guys? Is this thing clear? Yes. Good question. This was a good question, right? A question in which you need to think. Everybody, is this thing clear? Great, Kalai, Richu, Nishtha, Rahul, Keshav, Tamil, Ritu. Great. Good question. Good question, guys. Right? Yes. Great, Supriya. So you just need to remember these things. Now see, I've explained you this type of question once. Now if a similar question is being asked to you, now you can do it. See, the complete preparation, whichever competitive exam you're talking about, whichever competitive exam, the complete preparation is based on only one thing. All right, you need to avoid making mistakes. Which question you are talking about, Keshav? No. There must be different transaction. There must be different transaction then. All right. Or they must be asking you total number of lines. Or they must be asking you total number of lines. In this question, I have asked you only in the Lyman series only. If total is being asked for the transaction, if total is being asked, then your answer is difference into difference plus 1 by 2. Then your answer is 10. Total is being asked. Alright. But we are asking in your in particular series. Alright. So see, your complete preparation is to avoid mistakes. Now how can you avoid mistakes? See, there are high chances of you making a mistake when a question is new to you. If a question is new means you haven't seen that question, then there are high chances of mistake. Yes, there are high chances of mistake. But if the question is seen mean the pattern you have seen, you have understood the pattern, then there are low chances of mistake. Similarly, see, in this previous question, this was a new question for you all. So most of them were wrong. Now, why? Because the question was new to you. So there are high chances of mistake. You all have committed mistake. You all have got -1 marks. But now if the question is seen, now is it clear? Now the funda is clear. Now whenever you will attempt it, you will have a very low chances of making a mistake. Is this thing clear, guys? Entire preparation is based on your to avoid mistakes. More the number of questions you will practice, all right, more questions you'll be seeing, and more questions you'll be seeing, lesser chances of your mistakes. So practice PPP model. Practice and practice. Entire preparation is based on a PPP model. No. Ilakya, this type of question won't be asked in your infrared because you have your 4 lines in your infrared, na? This type of questions won't be asked in your infrared. Only Lyman and Balmer can be asked. Yes, I understood your doubt. All right. PPP model. Your entire preparation is based on your PPP model. Richu, type how to avoid silly mistakes. How to avoid silly mistakes by Nitesh Devnani. You will get some videos there. You can see it. Keshav, practice more questions and just keep distractions away, like your phone and everything you need to do. Just keep it away and try to concentrate on your studies. Your mistakes would automatically be reduced. Any question you want to ask me? Is today's class clear? Is today's class clear to all of you? Yes, yes, we will surely conduct a practice session. We are surely going to have a practice session. Yes. Amisha, sorry, you need to communicate there only. There's no response from their side. Nishta, you can just take any material and start solving it. All material are good only. All right. Yes. Rahul, CO2 structure is this. CO2 structure is this. We'll be studying hybridization. Don't worry. Hybridization is SP. Hybridization is SP. All right. And that is a question for me also. That is a question for me also, Misha. Yes. Keshav, how to find second ionization energy? No, no. We are only talking about ionization energy. First ionization, second ionization energy. We'll talk about in our periodic table. Don't worry. Yes. Any doubt? Any doubt, guys? At 9:30 a.m. we have our regular classes. All right. At 9:30 a.m. we are having our regular classes. Whenever you are planning to buy the subscription plan, see whether you buy the subscription plan right now or whether you buy the subscription plan 2 months later. All right, the pricing is going to be same. All right, so if you are planning, so you guys need to do it right now only. All right. So Nitesh YT, just apply this code Nitesh YT. You will get your 10% off. Alright, and if you buy the iconic subscription, I can be your mentor also there. Alright. Yes, yes. Yes, Nisha, there would be no attraction between nucleus and electron when an electron is present in infinite shell. Yes. Alright, so about the subscription plan, if you want to purchase, you can purchase it right now only. Why? Because see, the pricing is going to be same. Alright. So the better you, the earlier you start, uh, the earlier you start this take your subscription, the better it is for your preparation. All right. Thank you, Lakia. Thank you. Thank you. Share with your friends, guys. Share with your friends. All right. So the better it, the early you start your preparation, the earlier you need. See, what is the benefit of plus an iconic subscription? You'll get to know what kind of competition is being there, what kind of competition is there, what questions are being asked to you. All right. How can you analyze your test and everything? So it is better to purchase the subscription plan. Okay. I'll look into it, Nista. I'll look into it and I'll tell you. All right. No, no, stationary state. Stationary state also means your ground state only. Stationary state also means your ground state only. So it must be saying, I think so, the ground state has your lowest energy. And first shell has your lowest energy, na? Yes. It must be trying to say this. Yes. Your stationary state means your ground state only. All right. Yes. More doubts you can ask. You can surely ask more doubts. You can surely ask me any doubt if you have. All right. Okay. Then see you. Bye bye. Take care. If there are no doubts, I will meet tomorrow at 9:30 a.m. Bye bye, guys. Take care. Bye bye, everyone. Have a good day and practice questions. PPP model. Practice, practice, practice model. All right. All right. Yes, yes, Nishtha, but stationary orbit is especially for your ground state only. Yes. All right. Take care, everyone, guys. Bye bye. Bye bye.